How's it going, everyone? Welcome. Elier Gonzalez. That's right. So, in today's video, I want to look at the data fetching section from the model of the Joy of React, a course taught by Josh Komua, a software engineer that previously worked at Khan Academy and then at Gatsby. So, he made this course to understand now how you can apply React and what is the problem that it solves and how to do that. Okay, so the TLDR is that with React we can now describe is the state in which the UI must be, and this is the entire notions from the React team, their R&D, that they want to portray on their tool. So, in other words, what I'm doing here is just to understand what is the mindsets of the founders here. It's like any time that you want to make a change in your UI, this is the new snapshot, the new state of your entire application. This idea is quite powerful because now it allows us to keep track state changes, whether it's at the component level, which is what we are doing most of the time, or at the application level. So, for example, here what you're looking is a React application that any time that an action happen, all right, or in other words, an event happens, or something outside of the React application or JavaScript in particular happens, it's going to detect that and it's going to update the state properly. Right? So this is the new state of that. So this is the powerful reasons. And I went through the understanding is the little nuances of who makes this and what is the problem that Facebook has back then in 2011. And now, because traditionally when you develop applications, you use now is the MVC, which is the model view controller, as a way to split the development into this kind of applications. When you have now a client and a server, when you have two computers where one wants to consume that, known as the client, and the other is the provider or the server or these machines that host those files, right? And that's the TLDR of the entire web development. There's a very interesting topic on that, and also a podcast that I will leave the link below here, made by Grady Butch, a software engineer that works at the Air Force and over different industries as well. And he now focus mainly recently on architectures. Is like how do we now build applications that are easy to maintain and scalables, and also follow is the legal compliance and the ethic aspect of building that. So there is, in fact, I also took some notes from what he said because it'll be quick. It'll be quickly. It'll be quickly. I'll be quick here, which is there you got it. Is this one right? So the notion of the software engineer. I'm gonna make this very straightforward recap of this. So the term was coined by a. I didn't take note of that. I should. Let me do this very quickly. I think it's who the fuck holy moly the first software engineering I think it's Margaret Hamilton. Yep, Margaret. So Margaret Hamilton, I'm not gonna write that because I know what it is. So Margaret Hamilton actually mentions that there's something engineering-ish about building this kind of stuff, right? And because in the software engineer, you are trying to build reasonable, optimal solutions, right? And you can have perfect solutions, and you need to balance all of these dynamic forces that are involved. First is the medium, which is an elastic, fungible, and fluid medium, right? What you can build on top of that, which is the software aspect here, the medium. Also, you are constrained by the physics for the law of physics, which is you cannot send things faster than the speed of light. You can communicate faster than that, so you have to deal with that. And the other is how big things can be built, because now our hardware, despite all of these years of evolution, there is a limit of how big these things can be built. The other is the algorithmic, in terms of how much of that can be processed. All right. And he mentioned it, for example, the Bernoulli algorithm, which is essential for the creation of the cell phone, and the other is the fast Fourier transformer algorithm. I am not quite familiar with the fast Fourier transform, right? It's an algorithm that compute the discrete Fourier transform of a sequence of its inverse. And you may wonder, why do we even care about this, right? The fast Fourier transform. Again, this course is not about that. I'm just making a quick recap of this. Fast Fourier transforms are widely used for application in engineering, music, interesting, science, and mathematics. The basic idea were popularized in 1965, but some algorithm has been delivered as early as 1805. In 1994, Gilbert described the FFT as the most important numerical algorithm of our lifetime. Gilbert Strand, an American mathematician. And it was included in the top 10 algorithms, of the 20th century. Holy mo! What the French toast is this? What the French is a top 10 algorithm in the 2020s, in the 20th century? What? I didn't know about this. Okay. Oh, you think you're funny, right? Oh, you think you're funny. I'm trying to open this and say, hey, no. Oh, you think you're funny. Oh, you think you're funny. Okay. Okay, good. I go here. The leprechauns. Is this one? That's what I was looking for. Okay. Oh, holy moly. Okay. Guest editor introduction to the top algorithm. That was in 2000s. Holy moly. Metropolis algorithm for Monte Carlo. Simple method for linear programming. Krylov subspace iteration methods. The decomposition approach for math computations. The Fortran optimized compiler. QR algorithm for computing agent values. Quicksort algorithm for sorting. So sorting has been one of the most problematic stuff to do that. Fast Fourier transform, integer relationship detection, and fast multiple methods. That's interesting. Use random samplings to solve complex statistic, physical, and mathematical problems. The Monte Carlo methods. Simple method for linear programming provides an efficient way to find optimal solutions to problems with many constraints, crucial for industry. Okay. Privilege subspace iteration method, techniques for rapidly solving large systems of linear equations, essential for scientific computing. The composition approach, Fortran optimizer compiler, optimizing compiler, revolutionary programming by translating high-level code into efficient machine-readable code. QR algorithm for computing agent values, quicksort algorithm, a highly efficient, widely used sorting algorithm for organizing data, the fast Fourier ubiquitous algorithm that rapidly decomposes waveforms, vitals for signaling processing. Integer relationship detections, an algorithm used to find simple integer relationship between real numbers, and a method to calculate long-range forces in systems with many particularly efficiently. But again, he mentioned is this one, fast Fourier transform, a ubiquitous that rapidly decompose waveform for that. It's an efficient algorithm that computes the discrete Fourier transform (DFT) of the sequence, converting signal between time and frequency domains, typically in n log n time. It dramatically accelerates digital signal processing, enabling applications like audio image compressions, telecommunications, and spectrum analysis by decomposing large transforms into smaller ones. Okay. Even though I'm not quite familiar with, while a standard DFT takes quadruple operations, the FFT reduces this to n log operations. And even though it's quite And even though it's quite, for real? Oh, you think you're funny? Oh, okay. Doesn't matter. Oh, are you not gonna? Oh, okay. N log n. But this is this. Yeah, it just wants to. The visualization. So this one. Exactly. So what he mentioned is this one. Is almost linear, right? And that algorithm was like this, right? So in any case, so the algorithm is good enough, the algorithm is good enough to do so. But in any case, so here we are, right? This is fast Fourier computations, and I mentioned that because this is the top 10 algorithms here. I think that's quite interesting to look at that, or to create is a video about that. But here we are, right? And the TLDR of all of that is, as I was describing before getting to the FFT, is, hey, there is something engineering-ish about this software stuff. So Margaret Hamilton where she works at NASA. With as the years goes by, then the term software engineering was coined, and is to describe is what are the things that we need to do that in a systematic way, because here we are dealing with the medium, which is this elastical fungible medium, right? Is this fungible elastic and fungible elastic fungible and fluid medium, right? We also have to deal with the forces of nature, so you can send information faster than the speed of light, for example, and you have to get used to that, right? So you have to deal with it. The other is that how big things can be built based on the constraints of our hardware. And the other is the algorithm. So there are certain things that we can do, and those things must be done fast as possible. So the constraint of the algorithm is relevant to how many things can I do in a unit of second, which is great, which is powerful, right? So the more things that you can do in less time, the better off. That's the entire notion of this algorithmic aspect of the log n here. And this is another reason why I went through look at the Bernoulli algorithm, which is the essential for the creation of the cell phone. The other is the fast Fourier transform, which is a ubiquitous algorithm that is being used to transform. So, for example, videos and audio that it transform from one to another. There is another forces that is relevant to the human aspect. Is that ideally, if you want to build something, the largest deal that you want to have is 0, but you have to be pragmatic. So the next best the next best one is the 1, but there are certain things that a single person can build, and depend of the requirement of that system that you're building, and the additional constraints. So for example is the legal constraints. So the limit of the software that you can build, right, is now, or the teams that you can build around the software is impacted by the economy and the political reasons, because there are some systems that must endure an individual or a teams, whereas others might not. So all of these forces, and combining with the legal aspect of should I build these things? Is ethical to build this kind of stuff, right? So all of this is the forces that we as a software developers face, and we have to balance to each other. That's why I build is reasonable, optimal solutions, not a perfect one. So with that, right? And because here in React, the idea is, I listened to today's video, is to look at the data fetching. So React team create this UI or this JavaScript application where it say, because traditionally the way how you build now applications using the MVC model, the model view controller, as a way to now is build applications that can be consumed in this architecture. In other words, in this way how things are set it, for example, You have a bunch of people that are interested into piece of content that's gonna call now the audience or clients, and then you have now the provider or the server, right? That is willing to give that sometimes for free, others behind a paywall. Okay, so because to build these applications, traditionally we use is the MVC model, right? This is a model that was defined by the at IBM, right? It's like, hey, yep, exactly. So MVC was introduced by Thrik Rinsock. It's a Norway. Oh my god. Holy moly. Holy moly. Holy moly. Autocon. It's a discontinued line of image scanners sold by ECRM Inc., a subsidiary of AM International, from 1970 to 1990s. The inaugural Autocon 8400 introduced in 1975 what was flitter bad. But anyway, okay, so holy moly. Okay, that's quite interesting. um, so yeah, so it produced this assistant technology that was being used in docks, that was being used by shipyards. Okay, worldwide. Ringshock described his early Smalltalk and object programming conceptual. Again, the point of this, the point of this is to understand how do we get here, because at the end of the day, the only wealth that matters is the truth. That's the only wealth that matters. If you want to be wealthy, the truth is, and I think this is without any doubt, and people will agree upon that. True is the most valuable thing that can exist in the world. So not even the amount of money that they're printing right now. So the amount of money that all the combined banks has, they are no match for the value that the truth can have. And that is looking at this, understanding here. So this is how this kind of application were built. I actually part of that, there's some applications that actually use this kind of stuff. The problem is with this kind of model is that anytime that you need to have is a view, all right, a different view, you need to also replicate is the model and the controller, right? So you can have is several different views with the different models and the controllers, right? And if you, for example, have several UI, which is exactly what happened at Facebook. If you have now several UIs, like the chat applications, when you have now the message drawer and the message icon, the message drawer, and the chat, each one of those interface actually shares some of the functionality. So you have now is separate state of your application in each one of them. So the idea here is that if you want to now update a piece of information, you will have to do that in all of these different places. So far so good. But if you are now at these enterprise scales, you you want to do at the least amount of refactoring, right? And especially if you have now, if you are building software in large teams. So, but the TLDR of this is some of the folks at Facebook, smart folks, they create this at the R&D in Facebook. So they create now this experimental feature to say, hey, instead of having this particular architecture, right? The model, the view, and the controller, right? So let's going to have now is one piece of state bound to that, all right? And if you find yourself in the need to share that state across other different input or the UIs, you can do that. Because at the end of the day, what we are doing is to maintain a snapshot of the entire UI, right? That's the whole point of the React. So by going through is how you can create your own React, what React is all about, which is a nice little wrapper of any HTML elements, and also you can create your own custom markdown elements. But anytime that you create that elements, you are telling React that this is the state of this UI, right? And if you define now in each one of your elements now logic, for example, when you combine several of those React elements into a component, in this component that you add some logic to say, hey, for example, this is how things should look. And I think the most straightforward example is this is how things looks when it's in this state or is in this another state, right? But again, anytime that you define that information along the logic, right, you can now reuse that piece of information across all the other components. So what this things is doing, right, is by allowing us to create is a component, a JavaScript functions that describe is now how this markdown will look like, and a piece of logic that will indicate is what are the possible state that this component may have, right? A lot of the time, this is what you want, and we're starting by looking at, for example, how to do that using GSX. So what is GSX? What is the difference between HTML? What is the difference between a templated engine? And how you can now create is web application in this way, right? By starting small and then you scale that up, right? This is known as the atomic design. And once you know this, okay, there is now another question, is that how can we now is organize our files to develop this kind of applications, these web applications. So that's why I also look at the anatomy of this basic React applications, which is, hey, this is the entry point, this is the entry point. So you have now your index, you have the index.html, the index .ts or GS, all right, where you actually import React and then create that element and attach that element to that. So you tell to React, hey, let's going to render this components format, aka that's going to call all of these React application React functions, right? So you know what'll be is the state of the application, right? And when Then I look at how to do the most basic stuff, like rendering a list of elements or conditionally rendering elements. Some of the common elements that React gave us to us, like fragment, for examples, and also is the way to add in styles to our components. Okay, this is just the basics, right? And it took me like half an hour to describe that, right? And then when you look at now how you can describe this logic to provide some interactivity to your applications, all right? To describe what is the state of this application can be. So that is the interactivity and how you can do that using HTML, CSS, and JavaScript, using the add event listener, or by calling is a functions directly at the HTML tag, right? And the React way is that you're going to now is pass a functions to the React elements called event handlers, right? And it's React that we're gonna call the function that you pass to when that event happens. So because now there is some sort of indirections, so you don't have control of when this function is being called. It's React to handle that for you. This kind of scenario where your functions are being called for you, this is what separates a framework from a library, right? According to Martin Fowler. And why this is important, because this notion is what is going to describe is the behavior of React when it provides you some specific tools, right? So some of them are the user state. So when you want to now describe is what is a possible state that this UI can be, or to remember some piece of information, with user state you can do that and describe the UI at that particular moment. So, for example, if you detect an event that happens, you can now trigger that state by setting that state, and this up to React to now kick off a known as a core loop, right? Where because React is giving to you this particular tool known as user state, right? So it's going to remember a piece of information. So when you update that, React is it's going to pass through this workflow. It's going to pass through this assembly line. First, this is so who calls me this? Okay, so it's going to detect which components call that. It's going to execute that, right? And if that component contains more React elements, it will continue to call them until there is no more components. And on each call, what it's doing is to now creating a new snapshot, creating is a new state of the application. So what that mean is that on the trigger phase, which is the initial phase, to detect which components trigger that state updates, and during the rendering, which is just to figuring out what is the next snapshot here, you can look at this and say, hey, I already put it down here. Yeah, I already put it that because I do want to understand that. Understand it. Conditional renderings is okay. Okay. So, so yeah, so what I'm describing here, when I look at the render, not that render. Exactly, it's under React hooks, right? Use ID hooks. Okay, so I changed. Well, in any case, but the deal here is that React gave us this tool called user states, so we can hook into React by remembering a piece of information, and when that state change, we can, or React is going to pass through this assembly line process made of 3 phases. The trigger, who calls me that, and then it's going to now pass through the rendering, which is creating this new snapshot of the UI state, and then spot the difference and apply the bare minimum DOM updates on the commit phase. And when the DOM detect those changes, the browser will trigger a repaint to match the UI. So that's the entire process of using, for example, React, right? And as I look at how can we use, for example, is to describe not only primitive values but complex values, okay? The TLDR is that always return is the new state out of that. And also look at how can we dynamically generate is values for rendering a list of elements, and how what is the difference between an state and a props, all right? And when do I receive that props, or when I define an state, it is important to know where you put your state, because from that moment it will now trigger a cascading effect across all of those components if that state changes. So because this state is one of the core concepts on the entire React application, right? So when this change, right? Since here with the state we can, so here with the state we can use this to, okay, so with the state we can use this to remember some piece of information, okay, and then update them properly, right? And represent is a new snapshot, it's a new state of how our UI should look like. So because of that, right, depend of what kind of application you are building, whether it's a blog or a landing page, which you don't have, you can just use the local state of your components. But if you're building now game applications, heavy client interaction applications, then you might find is in the need to do that, right? So you need to somehow have some global state. And the other is, if you're building now back office apps or SaaS application, where now the state of the piece of information, the source of truth, now live on a database or somebody else, right? So most of the time, this is the kind of application that you're building, and here you have a different set of problems. So right now I'm actually building is a SaaS application for a real estate company, right? For the reports and yada yada and so on and so forth. But the idea is that building that kind of building this kind of application, right, is something that, for example, since now the state must, or the state live on a database, and then it's processed by an API and send me over to the client. So I need to somehow is to fetch the right data at the right time, avoid hammering the API, paginate that response, and somehow get the fresh state data so my data doesn't grow stale, right? And yeah, this is the okay, okay, yeah, this is the kind of problems. This is the kind of problems that that I have when building this kind of application. Hey, give me the right data at the right time. I want to avoid to hammering the API. I want to somehow catch the response. I don't want exactly. I want to somehow catch the response. I also don't want to make the response grow stale, so I need to synchronize with that, and I want to be able to access through the data, so paginate the data. So this is the kind of problems that now I'm going to look at that, particularly on the data fetching, and how now React describe something that is important when you're developing this kind of application, known as the components instance. So not only that you have is this notion of the snapshot, but also of the components instance. So when you call, or when React called your components, it's actually creating is a long living object that is going to be updated through the entire app lifecycle. So you have now your app. So you have now your components instance and the snapshot, right? This is the two notion, the two concept that React has. So the snapshot is that the internal representation of the virtual DOM that describe is the UI at that particular state, and when there is a state change, so React will generate this new VDOM for us. That's one, and the other is that when you have a component, you have now a life cycle, or in other words, React, when this component is mounted, is visible for the user, it has now a life cycle known as the components instance. So this is the two notions here to develop this intuition about React. So you have now the components instance, and this is when you have things like the unmounted or the mounted or the unmounted. All right. So you have now this notion of the components instance, and also if the snapshots. So the components instance is describing is what is the information that this component has at that moment, right? And the snapshot describe is what is the entire UI will look like, or what is the entire UI? What is the entire UI state for our application, right? At this moment. So one of the things is per component, and the other for the entire application. So this is the notion of the components instance and the snapshot here. So if I ask Claude here real quick, right? The notions of component instance and rendering is that component instance are created components instance are created when React call our component at the root.render at the root.render component, right? Say app, for example, right? Exactly. So components instances are created when React call our components at the root.render. Components, exactly. So components that may be visible or not, but they are present into the React internals. And then you have now the snapshot or rendering or snapshot is an internal record, is an internal React record of how the UI must look like, or yeah, how the UI must look like at a specific time, right? So this is the notion of the components instance and the rendering, right? Is this, right? Is this. So when React encounters a component in the JS tree, it creates an internal representation of that component and a fiber node. This instance lives in the React internal fiber tree. This instance lives in the internal fiber tree and persists across renders. It holds the component states, hooks, props, and position in the tree. In the tree. Yeah, it holds the component state, hooks, props, and position in the tree. It holds the component state. This instance lives in the React internal fiber tree and persists across renders. It holds the component state, hooks, props, and position in the tree. The key nuance instances aren't just created at root.render. They are created or destroyed whenever the tree structure changes. If a component appears conditionally, if it is instance is created when it mounts and removed when it mounts. But this is this notion of the React internal fiber tree. And then you have rendering and a snapshot. This needs a bit more precision. Rendering in React means calling your components to produce the new JSX description of the UI. Okay, I can be more precise like that. So rendering or a snapshot. Okay, so rendering, it means that it reacts calling your components to produce is a new description of the UI, aka is a new JSON object and describe the UI. Each time React calls your function, it captures a snapshot, but that snapshot isn't really a separate record. It is the JSX output, a three React elements that React then reconciliates against the previous fiber tree. And it's interesting. Against the previous fiber tree out of what actually changed in the DOM. So the flow, it's render, call the function, it gets the new element. Is an is an internal, exactly, it's not an internal record. So rendering in a snapshot is an internal recreation, or is an internal, is, so rendering or snapshot is React calling your component to describe, exactly, calling your component that generate a JSON describing is the UI state, or describing the UI at that specific moment, at that moment. Mm-hmm. 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 Is React calling your function component or render for classes, and the result is a React element tree, plain JavaScript. Oh, okay. Research for your sources. So is this notion of the components instance and the snapshot of the rendering. So when React call your components, is creating now this tree data structure known as fiber. Mm. Mm-hmm. Mm-hmm. The fiber tree is a linked list of fiber nodes organizing as a left child right sibling tree. Okay. Holy moly. Mm-hmm. 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 Okay. Mm-hmm. Mm-hmm. So, so this is what the React Fiber is exploring here. Mm-hmm. Mm-hmm. Versal. Mm-hmm. 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 Okay. So, so. Mm-hmm. Okay. So it is a single linked list. It is a single linked list of child nodes. Exactly. This is one linked list and the other linked list. Okay. Okay. Got it. Okay, so things started to make sense here. This is the reason why uh in some couple interview question they say, hey, can you create a linked list? Can you create a stack, or a queue, or what's the other one? The examples that they love to call um um holy moly, it's the um catch LAU, you know, least recently used, right? Can you create this least recently used catch? A widely used catch is strategy that events the least recent the access items when the catch reaches its capacity. This approach is based on the principle that data not accessed for a while is less likely to be needed soon. Evasion policies and time complexity and use cases. Idea for performance critical systems like web servers, database, operating systems, and CDNs. Key implementation here. A common and efficient implementation combines a double linked list, maintains the order of access most most recently used at the head and least recently used at the tail, and the hash map. Provide constant timed access to throw a hash map, bro. provide constant time access to any key value pair. When an item is accessed, it is moved to the head of the list, making it is as MRUR. On insertion of update, if the cache is full, the tail LRU item is removed. So this is the reason why they use this kind of stuff, you know. Oh, and they have their own things like that because they want us to use now this algorithm for that.
Hi, in this video we are going to talk about
Okay. And this is quite interesting, man. Register address, corporate communications address. That was not that while ago, bro. System designs tutorial. Like this. Scalability, database and design systems, and design and consistency and all that kind of stuff. But the whole point of this is that how can you use the existing tools that we have to solve common problems, right? That's the whole point of this, right? That's the whole point of this. That's the whole point of this. Holy moly. How can you use the existing tools to solve common problems? Alright? Problems of sorting and ordering. Okay. So now this is a linked list here. This is why I was actually looking at this, you know. How old is this? 2024. The key improvement in React Fiber since React version 16, such as concurrency, automatic batching, and new hooks like. Okay. Makes a lot of sense, right? So you have now render phase. React builds a new work in progress tree, a copy of the current tree in comparison with the previous one. And then on the commit phase, in the two trees, React maintains two trees, the current tree, which is displayed on the screen, and the work in progress tree. React swap pointers. So the idea is that I'm developing is this notion about this components instance between the components instance and the rendering, the snapshots and the components instance. Okay, so why this is important? Well, because as we're going to look at different couple exercise or different. So as I'm going to look at different couple, how do you want to call it? All right. But it's that as we so the whole point of this is because React expose certain internals known as hooks, aka specific tools that allow us to get into React and then work with that to solve specific problems. One of them is so there's several hooks, right? And the idea of these hooks is because instead of reusing components here and there, because that was the only tool that we have in React, now the React team says that's going to now create is a particular ES model, JavaScript models, when you put all of the logic that you need to, so you don't pollute the DOM. So this is the idea of this. So you have now custom behaviors or common behaviors that React teams detect, and they create these particular hooks for those edge cases, right? Right. For those edge cases, and yeah, that's one. Or you can create your own logic. So the most common case or the most common app level behavior that the React team have to build was, hey, the use ID or the use ID, for example, we need to have some way to have a global records of all of this. We need to have a global records. For example, when we want to add now unique identifiers to our forms or labels, right, into a checkboxes, and it makes quite a sense. And the other hook is they use ref. So you want to hold some piece of information, usually a DOM. So you want to now interact with the with that DOM, whether it is the audio, video tag, a canvas, you name it. And there's some rules to use this hook. Whether it is you put always at the top, and you use them inside of your React components, except for custom hooks. And there is another hook that is the most controversial, or perhaps the most the most the most or the most misunderstood. It was the most misunderstood, and this is something that I'm gonna call later in this in today's video, known as use effect. So I'll be right back.